Good morning, students. Today, in our session, I am going to discuss the new topic from chemistry side, that is matter around us pure? First, I am going to explain pure substance. What is pure substance? The substance which is made up of same kind of particles. And the classification of pure substance elements. What is element? Element is the pure substance made up of same kind of atom. So gold, RmAu. Next, silver, Ag. Iron, so ferrous, Fe. And another one is compound. Compound is a pure substance which is made up of same kind of molecule. And the best examples carbon dioxide, ammonia, and water. In compounds, atoms are combined with fixed ratio. So these are the molecular structure of water, ammonia, carbon dioxide. Next I am going to discuss about a mixture. What is a mixture? The mixture contains more than one pure substance. And the mixture classified into two types. One is a homogeneous mixture, other one is heterogeneous mixture. Homogeneous mixture. In homogeneous mixture, components are combined with uniform composition. Heterogeneous mixture consisting of non-uniform composition. The best example of homogeneous mixture, salt and water. Whereas heterogeneous mixture, sand and water. And the flowchart, matter can be classified into two types. One is a pure substance, other is impure substance. And pure substance can be divided elements and compounds, whereas impure substance, best example mixture. Mixture can be divided two types, homogeneous and heterogeneous. Solution is the best example of homogeneous, whereas suspension and collided particles are the best examples of heterogeneous mixture. Now I am going to explain about heterogeneous mixture and its properties. Sand plus water. This is the best example of heterogeneous mixture. In heterogeneous mixture, components can be seen very easily. It is important. Components can be seen very easily. Next one is heterogeneous mixture have large particle sizes. The size of the particles are very high. And components can be separated very easily by simple technique. Through filtration process. If you can take sand and water, those can be separated by filtration. Now, homogeneous mixture and its properties. And best example, sugar and water, salt and water. And the properties. Here we can observe the uniform composition throughout. So dissolving percentage completely done. The components are not visible due to less size of the particles. The particle size of homogeneous is very less, that is, the size of particles almost all less than of 10 power minus 7 centimeters or 10 power minus 9 meters and 1 nanometers. And components cannot be separated easily by simple technique through filtration process. So these are the properties of homogeneous mixture. Next, solution is homogeneous mixture, and solution is homogeneous mixture and solution consisting of solute and solvent. Simply you can say that solute plus solvent is equal to solution. When water acts as solvent, that solution can be called as aqueous solution. And see some more examples. These are the solution. What is solvent? So these are examples of aqueous solution. And I have taken sugar solution. Your sugar solution is made up of 2 grams of sugar and 100 grams of water. Here 2 grams of sugar can be called as solute and 100 grams of water can be called as solvent. Why? Because here 2 grams of sugar is a less component and 100 ml of water is a large component. So what is solute? Solute means the component that is dissolved in the solvent. So the component which is dissolved in the solvent can be known as solute. For example, 1 gram of copper sulfate and dissolved in 100 ml of water. Here less in quantity is 1 gram of copper sulfate. So this can be called as solute. It is a simple technique. Next, solvent. What is solvent? Solvent means that dissolves other component. That dissolves other component. So the component can be called as which dissolves. The component can be called as solvent. Simple technique which is more in quantity. Here 100 ml of water. That is the best example, solvent. So in a solution, we can be seen solute and solvent. So solute plus solvent. Solute means the component which can be dissolved. Solvent which dissolves. And types of solution. How many types of solution we are having? Unsaturated solution, saturated solution and supersaturated solution. Unsaturated solution. What is unsaturated solution? Here solute is very much less than of required saturation. For a dissolving capacity of the solution, solute is more required. Such type of solution can be called as unsaturated solution. And saturated solution. What is saturated solution? Saturated solution, the solution that has dissolved the solute as it is capable of dissolving. So solute almost all equal to the dissolving capacity, required saturation that is. And supersaturated solution. Your solution is more than of required saturation. Then we need not to require the solute in this case. So these are the best example of supersaturated solution. Supersaturated solution. And finally, supersaturated solution is unstable. Among all the solutions, supersaturated solution is unstable. And solubility. What is solubility? Solubility means the amount of solute presented in the saturated solution. Here simply the exact amount of solute presented in the given solution. So that is referred as solubility. Solubility depends upon mainly one of the factors, that is the temperature. For sodium nitrate solution and potassium nitrate solution, sodium nitrate formula NaNO3, potassium nitrate KNO3 and ammonium chloride NH4Cl. For these solutions, the solubility increases for increasing temperature. So that I can easily say that solubility is directly proportional to the temperature. From this graph you can observe. Next, some solutions like sodium chloride solution, by increasing temperature For sodium chloride, the solubility remains same. That is, here the solubility of sodium chloride is constant by increasing temperature. And some of the gases like ammonia, NH3 and HCl gas and sulfur dioxide, for these gases, their solubility decreases along with temperature. Therefore, we can say that solubility and temperature both are inversely proportional. So, from graph you can observe solubility is inversely proportional temperature for these ammonia and sulfur dioxide. And see the graphs. Effect of temperature on solubility. Some solution increases and some solutions remain the same and some solutions decreases. And next, concentration of solution. What is concentration of solution? So how much amount of solute presented in the solution? How much amount of the solute presented in the solution? So that we can express the concentration of solution through different methods. One of the method is mass percentage. So mass by mass percentage for calculation of concentration of the solution, mass percentage equal to small m by small m plus capital M into 100. What is small m? Small m is mass of solute and capital M is mass of solvent. Small m plus capital M is mass of solution. Solution means solute plus solvent. And the second method of expression of concentration of solution, that is volume by volume percentage. So V percentage equal to small v by small v plus capital V into 100. What is small v? Volume of solute and capital V volume of solvent. Small v plus capital V is volume of solution. And problems on mass percentage. See the problem. A solution contains 40 grams of common salt in 320 grams of water. Calculate the concentration in the terms of mass by mass percentage of the solution. So first of all, we are going to discuss about the given terms. Here small m is given 40 grams. Why? Because relatively less in quantity. And water 320 grams. And mass percentage formula, you know that small m by small m plus capital M into 100. Small m is 40 and capital M is 320. 40 by 360 into 100, that equal to 100 by 9. That equal to 11.1 percentage. Now second problem. When 10 grams of sodium chloride is present in 100 grams of its aqueous solution, calculate the concentration in the terms of mass by mass percentage of the solution. So here is also we are going to focus on given terms. So relatively less in quantity is sodium chloride, m equal to 10 grams, and aqueous solution means small m plus capital M equal to 100 grams is given. Now mass percentage formula, small m by small m plus capital M into 100. Small m is given 10. From problem solution is given. That means small m plus capital M is given 100. 10 by 100 into 100 equal to 10 percentage. Now problem number 3 related to volume by volume percentage. 15 ml of hexane is mixed with 45 ml of heptane. Calculate volume percentage of the solution. From given terms from the problem, relatively less in quantity is here 15 ml of hexane, that is small v, volume of solute. 15 ml, and relatively large in quantity 45 ml of heptane, that is capital V. Capital V means volume of solvent, 45 ml, and the formula small v by small v plus capital V into 100, 15 by 15 plus 45 into 100, 15 by 100 into 15 by 60 into 100, 15 ones are 15 fours are 4 ones are 4 25s are, so 25 percentage, here volume percentage is 25. And next time we will discuss the Tyndall effect through solution, suspension, and colloidal particles, and also some more separating techniques we will discuss. Thank you.